Things Policy, a daily podcast supported by Pragati, a flagship media initiative of the Takshashila institution. We're a bunch of policy nerds based in Bengaluru, and we like to bring a fresh perspective to Indian affairs and an Indian perspective to global affairs. So grab a cup of coffee, sit back, and join us for today's chat.
Hello and welcome listeners to another episode of All Things Policy. Today as my guest, I have Shambhavi Naik, who is the head of research at Takshashila and also is the chairperson of Advanced Biology program, where we explore emerging technologies in biology and biotechnology. Hi Shambhavi, how are you?
Hi, Harshit. I'm sorry I might cough throughout this session, but I really look forward to today's discussion. Hi to all our listeners.
Yeah, and Shambhavi, thank you so much for coming to the podcast even though you are sick. Thank you. So today there was an interesting development basically in India and as well as in Kenya. So India recently approved the DMH hybrid, that is the Dhara mustard hybrid 11. It is a genetically modified strain of mustard which was been developed from some time, and this was basically developed to help reduce our reliance on imports of mustard oil from outside. Basically, we have a deficit of 55-60% according to various sources in edible oils, and it basically cost us more than 1 lakh crores to import this. And we also have a very low yield in mustard, that is somewhere around 1200 kgs per hectare as compared to the global average of 2000 kgs per hectare. And Kenya also reversed a decade long ban on GMOs. They have a drought like situation in which they are reversing bans on certain GMOs, and they have now lifted the ban everywhere. So Shambhavi has also worked on this, and we will have a conversation of what are genetically modified organisms, why was there opposition to this, and what is the safety, and how is it a good move or maybe it is a bad move. So Shambhavi, can you give us a short introduction on what the history of GM mustard has been and what basically are GMOs?
Right. So, genetically modified organisms are basically organisms where you have taken DNA or nucleic material from a different species and introduced them into the species that you want to target. So, for example, BT cotton has this genetic sequence from Bacillus thuringiensis that produces a toxin in the cotton that kind of kills off bollworms, and therefore the plant is safe without the use of additional pesticide. Similar to that, we have these hybrids, the GM mustard, which also has genes from outside of the mustard species, right? So this typically is what a genetically modified organism is. The GM mustard has had a very interesting story. It was first research on it was first started in the 1980s. The Deepak Pental team worked on this at Delhi University, and the idea was obviously to improve oil and meal quality. So oil seeds, may they be soya, rapeseed, or mustard oil, or mustard seed. They basically provide two things. They provide oil, which is used for cooking, or meal, which is used in the animal industry for feed purposes. Now, India imports a lot of oil, as you rightly said, and a lot of, say, the soya oil or canola oil that we get is mostly derived from GM crops, because outside of India, there is a lot of production of genetically modified crops, particularly in the soya segment. So we have always been importing GM soya oil. Very recently, we also started importing GM soya meal for poultry because we just could not meet our domestic demand with domestic supply. This is why GM mustard kind of is trying to fit in, is that we are trying to create seeds which will give higher yields than normal hybrids, and therefore we will get more production without necessarily having to increase the area under cultivation. Right. So the team has been working for a long time. They've tried a variety of different approaches, which I won't get into the technicalities of, to kind of create these hybrids, which will be giving better yields. The DMH11 that you mentioned was first developed in 2002, and they showed through trials that it kind of increases yields to about 28% more than the mega variety that they developed, and 37% more than zonal check varieties. I am getting all of this data out of a tweet that was tweeted out by K. Vijay Raghavan, who is a former principal scientific advisor to the government of India. We will tag the tweet in the description as well. Right. So they did a lot of studies to show that it was safe for human consumption. The hybrids using the similar systems in other plants have also been used across various countries and shown to be safe. There have been no reports of them causing any ill effects. There were some reports of the herbicides which are used in conjunction with these hybrids that they can cause cancer. But the Kenya ban on GMOs kind of came out of one of these. There was a study which showed that the herbicide could cause cancer in mice, and based on that one study, Kenya basically banned GMOs a few years ago. That study was later shown to be problematic because they did not have enough population that they had studied. And reviewing all of that data,
The
huh,
study being retracted finally
the
because
study
of
had to be
small.
retracted.
Mhm.
Yeah. And so now Kenya has revoked that while reviewing stuff. I'll come to the Kenya study a little later. But basically, there has not, I think, evidence for the safety of GMOs has been presented in both manners. The WHO has come to a conclusion that GMOs are safe for human consumption. But I guess context dependent studies are extremely important. And the thing that I really want to drive home in this context is that we have to take all GMOs in a case by case manner. We cannot say that GM mustard is bad because all GMOs are bad, right? Because the technology is bad. That will not get us anywhere. We need to do a case by case study to show that GM mustard is safe for human consumption. They also did studies to show that it was safe for bees because bees are the main pollinators of GM mustard. So those studies have been done. That they're safe for poultry consumption, right? So a number of these studies have already been conducted since the GM mustard was made in 2002. So since then, they have done a number of these studies. I think Vijay Raghavan also pointed out that they have spent about 80 crores of publicly funded research, right, that has gone into the
Mhm.
making of this GM mustard. So all of the studies are done. The GEAC has now reviewed all of these studies, and hopefully, based on the studies, they have now approved the GM mustard for commercial cultivation. So under IACR, so there'll be further obviously supervision that will be done. What we hope to get out of this is higher yields without any additional
Mhm.
input of water or pesticides. There will be, this is going to be a public sector hybrid, obviously, because it has been mainly funded by the public sector. So we hope that there will not be a lot of increase in the seed price. And there was an estimation that Vijay Raghavan made that farmers can earn up to rupees 323 crores more. Obviously, that was, we need to see how well the adoption goes, whether the crop will actually come to market, what will be the yield increase in real fields, etc. But overall, I think the idea is that let's bring in this technology to improve yields without the additional input of a lot of other water, pesticides, etc. that need to be put in.
Okay, so summarize GM, at least GM mustard, will be getting us better yields and we'll be using less pesticides and maybe basically less input, less water, less resources. We'll be getting better yields, so better sort of like availability of oil and better availability of feed for the animals. And also, this will help us in reducing our carbon emission. So it's all good. And the latest data which I can shows that BT cotton, which was adopted somewhere in 2002 or 3, an adoption of 95 to 96%. So everything is good. This is approved. This is safe. And so why is there still opposition to this? Why are people, there is safety data which shows that it is good. There is better yields. There is less input. So more money, more safe. So what's the problem?
So there's been a narrative problem with GMOs for a long time, and I think it is true of a lot of emerging tech that comes in. We don't always understand the risks, right? There have been cases where herbicides have caused cancer in farmers. Obviously, in India, we know that with BT cotton, there have been issues related to farmer deaths, which have been linked, I think, to BT cottons in narratives. But agriculture in India is an extremely complex system. It's a lot to do with agriculture, financing, for example, monitoring of the crops that are coming in. So yes, there is a risk element to using a GMO. Whether that risk element translates to an outright ban on all GMO crops is something that is probably disproportionate. I think there is some merit to using GMOs, but there also has to be a lot of education around using GMO. So, for example, when we say that, oh, yields are going to increase. So, let's take the case of BT cotton. BT cotton is supposed to protect from bollworm, and it did. And after a few years, it stopped protecting. And that is something that we should have actually been able to anticipate because that is how evolution works, right?
Mhm.
You have the bollworm, which will eventually evolve a way around surviving the toxin that the cotton plant has. And so you need a different variety of toxin that has to come in. In nature, this would have happened automatically because BT cotton is a lab produced seed. It did not happen. And so that's something that, as a policy perspective, we need to be careful of, anticipate, and try to protect, right? If we don't do that, then what happens is it is termed as, oh, GMOs have failed and farmers have lost their crop. This is not a bug of the system. This is a feature. Evolution is a feature of all living organisms and also of GMOs. So there's a way that the science has to kind of catch up to the experiment in the petrol pit has to catch up with the experiment in the actual ecosystem, right? So that is something
Yeah.
that we have to be very careful of. Second is regulation around the use of herbicides, pesticides, etc. That those have to be stringent. And again, education is required to make sure that they're not being overused. In India, I think a lot of this is driven by farmers talking to each other or talking to the guy who's selling them the fertilizer, right, the herbicide. So that information is to trickle down correctly, and that is a very important angle of putting GMOs through.
Yeah,
So I
so
think
the science has to play catch with the regulation, and the regulation also has to play catch with the science. Emerging tech
right.
and regulation has to have a balance, and we also need continuous improvement in at least in the this sector, GMO sector, for our yields and our outputs to be still be as productive as they were on day one. So Shambhavi, I'll take a short break and get back.
Sure.
So listeners, will go for a short break and come back. Hello, listeners. Welcome back to our episode of All Things Policy. So, we have Shambhavi, and we were talking about how GMOs work, how GM mustard was introduced, is finally approved in India. So, coming to Kenya, Kenya recently lifted their ban on basically all GMOs. They had banned them since a decade. And this was after a small study which showed that GMOs in particular raised. So the study with the small sample showed that GMOs increased cancer in mice, but it was later retracted and everything. So Shambhavi, do you think Kenya's step is a step in the right direction?
I think Kenya's step right now is one of desperation. They've been a drought for many years, many seasons now. They're not able to provide food for their population, and therefore they have taken this step of allowing cultivation and allowing import of genetically modified organisms. I think sometime earlier this year we also had Sri Lanka, which had economic depression set in because one of the contributors for that was their organic farming. So they actually moved the entire country shifted to organic farming toward proclamation, and the crops failed, and so they were not self-sufficient in food. They had to import a lot of food. That caused their bills to increase, the foreign dependence to increase, and that was named as one of the contributors to them defaulting on their international debts. I think these two stories tell us that banking on any one technology or any one agricultural technique is going to cause problems in maintaining food self-sufficiency. There have been recent calls made in India as well that we need to move to organic farming as a country. But again, given the way climate is changing, I don't think natural evolution moves at a rapid enough pace to play catch up with the rate of climate change, which means that we might see species being wiped off very quickly because they're just not able to catch up with climatic changes, right? And in that context, having this technology whenever we create crops in the lab is going to be crucial. Whether we deploy them right now, whether we just build the expertise and keep it, is again a question that has to be made, that has to be answered in a case by case manner. So, for example, for mustard, for soya, etc., we know that there is a requirement because we have foreign dependency. So, it makes sense for us to at least try GMOs in that context. For a number of other grains where we have food self sufficiency, we might not want to create GMOs at this point of time, right? But we certainly need to build that expertise because tomorrow, if we are in Kenya's shoes and we do not have the expertise in house of creating crops, I mean, these crops are not going to be created overnight. Right? The GM mustard is a classic case. It started in 1980s. They developed the DMH in 2002 and it has got approved now. So it has been a long run, right? So we cannot develop these expertise overnight. We cannot develop these crops overnight. So having this expertise is going to be very important. We don't want to have unnecessary foreign dependence on something that we're actually good at. So I think from that context, what Kenya has done has come at a moment which is very bleak for Kenya's food sufficiency. And I think what we have now, and I hope all the concerned ministries also give approval, there is no further ban on the commercial release of DMH mustard, comes at a good time because it allows us to build expertise. It sends a signal that we are open to GMOs, that others in the sector can also now start creating GMOs. I mean, GM brinjal and mustard were the two GM crops that we have championed for a long time that are yet to see the light of day. But hopefully there'll be more coming based on this approval.
So we have to develop that expertise. And I agree with that. We should decrease our foreign dependence on things such as maybe mustard, in which we are able to, with the help of GMOs, able to grow our own crops and with good yields and maybe better prices. But I think we also need to identify critical sort of like crop which are essential for us and maybe may get disturbed due to the changing weather patterns. We also have to develop expertise in those crops. Maybe, I don't know, this is an hypothetical example. Maybe we find out that rice is very dependent on temperatures, and the areas which we grow rice, they'll see a temperature variation which will lead to crop failure. So I think we also have to identify species such as these, crops such as these, and also work towards genetically modifying their and getting better species which are more resilient to climate and have better yields and give us better food security and better prices.
Sure, I think there's a lot of science that goes behind picking the that identifying the crops. I think there's certain pollination methods, etc. That work has mentioned for the mustard as well. There were two or three different techniques that they tried before zoning on the genetically engineered one. The rice is actually something that we spend a lot of money in doing research on. So there are quite a lot of variants of rice actually that the IRI develops. So yeah, so basically
So
there has to be a lot of science that goes behind what you pick to develop. There is one outstanding question I think that we have not yet answered, which is of biodiversity. A lot of fear comes that if you have GMOs, then you will lose a lot of the Indian strains, which kind of then speaks to whether farmers are more amenable to picking GMOs because they see advantage in it. Are there other ways we can develop to protect our biodiversity? And I think this is more of a policy question that needs to be answered. Again, not saying that, hey, because biodiversity has to be protected, let's not bring GMOs. I don't think that is going to answer any questions, particularly questions of food sufficiency. I think the other aspect also here is that we need to realize that as India economically improves, we move from food sufficiency to nutritional sufficiency. So people are no
mhm.
longer just desirable of having food on the plate, that food has to be nutritious. And this is again somewhere that GMOs can play an active role in creating fortified plants, delivering vitamin A and C, etc., through crops. So I think that's a very complex kind of science question. How do we do that? But I think GMOs will be the answer as long as it makes scientific sense to tackle malnutrition problems in India.
So GMOs would help us in moving from the question of hunger to the question of malnutrition.
Yeah.
As we are going in the right direction majorly in solving hunger in India, GMOs would help us in solving malnutrition to a large extent. Yeah, that's a good, nice observation. So Shambhavi, what do you think are sort of what should be our governance and regulation and policy direction in GMOs? As you talked about being case specific, you talked about continuous advancement and continuous identification of species to develop. You talked about getting that safety data out, getting continuous trials and developing new species. What do you think are other ways we can, what should be a correct policy sort of like direction in the GMO space?
I think number one, as you said, we need to get the safety data out. I think we have to be very transparent with all data that comes to GMOs. I think it has GMOs has become such a controversial topic that people have lost faith in the apex government bodies which even determine approvals, right? So the GAC which approved GMOs, there have already been articles in the newspaper saying that the GAC is a puppet of all of these private companies. That is where they have approved GMOs, etc. I think that lack of faith in institutions is really worrying. And one way to address that is by institutions being more open in sharing data around safety and the kind of studies that have been done to show safety, right? That's number one. I think the way we can look at GMO policy is to try to be a little more open and not judge it for what conventional crops do. So I think people have been vehemently opposing GMOs without really understanding the technology behind GMOs. The narrative has become so hijacked by them that it's really difficult now to kind of,
Change it.
yeah, to move forward. And I think only transparent kind of data sharing will address that. Again, farmers groups have been either opposing or wanting GM crops. In Maharashtra, I know a few farmer groups which actually smuggled in GM crops and seeds and sold them because it like gives better yield. It's a more complex dynamics than I think than can be simply explained. But I think from a policy perspective, we have to be more transparent, we have to be more open, and we have to be cognizant of the fact that all genetically modified organisms will cause an evolution in whatever that they're targeting, right? And we have to be prepared for that evolution. We can't say 2 or 3 years down the line, oh, this failed, because Again, it's not a bug. Evolution is a feature of all living systems. I think that is one thing that we have kind of not taken into account sufficiently enough. We need better monitoring of GMOs. And I think
So we
only
need,
with sorry, and I
yeah,
think only
please
with
go.
better monitoring can we actually try to figure out whether the yields have actually increased, what has been the impact on farming, what has been the impact on ground resources. But if we don't give them the chance to do any of that, we are just kind of losing the chance of using a technology that could have been beneficial to us. The other technology that is coming in, which is genetically edited plants, that is actually quite exciting because they don't use DNA from outside the host species. They only change the intrinsic DNA, and those have been put outside the purview of GMO. So those are not subject to the same kind of regulation. And so I'm really excited to see what kind of exciting crops we see that are developed using genetically editing technologies as opposed to gene modifying, because I think those are going to be the future of Indian agriculture.
So, Shambhavi, fundamentally, there's no difference between gene edited organisms and genetically modified. Modified, I understand there are certain genes which you bring from outside, but gene editing, you're also removing certain genes which may have certain effects. So, policy viewpoint, you are removing them from the normal preview, but they're also sort of you're modifying their genetic makeup only on a genetic level.
Yeah, and
So,
so is natural breeding. You're changing our genetic material. So the idea is with gene editing, you are making so small changes that they could have occurred naturally. So those
oh, okay.
subsections of gene editing, gene edited plants are going to be removed, where you cannot actually tell.
So these are favorable natural accelerated natural selection
Yeah,
in plants.
yeah.
Okay.
If you use gene editing to actually create a plant which is very different from the naturally occurring one, those will be still be subjected to GMO rules.
Okay. Shambhavi, any closing comments before we go?
Yeah, I think what we have seen with the GAC is quite exciting. That the fact that mustard has got approval. I hope people are a lot more open in receiving and adopting it and giving it a chance. And even if it doesn't work, right? This is a technology that we have to invest in, because we can't just say we are not going to create expertise in something that we might as well require in the future. If it doesn't work, we have to try again. If it doesn't work, doesn't mean that all GMOs are bad. This bucketing has to stop. The technology is useful. Its use is very human dependent. And so the problem is not with the technology. The problem is with, if there is a problem, it's going to be with how we use it. So let's be careful about using it. Let's not get cornered into saying that, no, this is all bad, let's not do it at all. Or it is all good and let's just do GMOs. Let's use our intelligence in kind of creating proper context and assessing the correct risks and potential of using GMOs and using them in a manner that is going to be useful for everybody.
So thank you, Shambhavi, for the wonderful talk. And we hope to see maybe better regulation of GMOs. And I think this technology holds great promise. Thank you, listeners.
Thank you, everyone.
If you liked our show, don't forget to check out other interesting podcasts on the IVM network. You can tune into them on the IVM Podcast app, ivmpodcast.com, or wherever you listen to your podcasts. You can also follow IVM on social media. The handle is at IVM Podcasts on Twitter, Facebook, and Instagram. And hey, if you'd like to dive into Takshashila's research on technology, strategy, and economic affairs, check us out at our Twitter handle at Takshashila INST or our website takshashila.org.in.